Welcome to Java Video Tutorials. This is lesson 4. We're going to learn about the math class, and we're also going to learn the Java documentation and how to interpret it. So the first thing is, let's go ahead and open up the documentation. And so you're going to have to go to your web browser. Here's Firefox, and let's go java.sun.com. And there we have it. Let's go now down to this APIs right here and click it. And we want Java SE6, and we want Core API Docs 6 right here. So click English or Chinese or Japanese, whichever language you may happen to speak the best. And this is going to be the documentation window. We have 3 different sections right here. But usually I just worry about the all classes section and this main section here in the middle. So let's scroll down the all classes and find the math class, because that's what we are working with today. M-A-T-H, Matemáticas right here. Okay, so it says class math, or the math class. And you see it's java.lang, so it's saying that it's in the java.lang package. We'll learn about that later. And also it extends this java.lang.object class, and we will also learn about that later. So right here shows the definition, the definition of the math class. So public final class math. We'll learn more about that in probably lesson 5, maybe 15, I'm not sure yet. And it tells you all about the class in super detail right here. And it tells you it's been around since the very beginning, JDK 1.0. So that's a good thing. Field summary. This will summarize the different variables that are in the math class. Since the math class is kind of a special class, and it says static for everything. Static double, static double, static double, static float, static int. That means that you can basically access these variables without creating an object or an instance of this class. So we can just go ahead and say, hey, I want to know what pi is, and we don't have to create a math object, not that we could if we wanted to. So to show you all this, let's go ahead and minimize the documentation, and I'm going to open up Dr. Java. So bear with me as Dr. Java starts turning its little engine, and here we go. Alright, here's Dr. Java. We're going to do this lesson in the interactions window once again. So let's go ahead and start out by typing math. And I'm going to go back to, that's not it. Okay, I'm going to go back to the math class here, and it says static double E, okay? And this E is capitalized. So let's say we want to access that value. And it's the double value that is closer than any other to e, the base of all natural logarithms. Can't say that right. Logarithms, which is about 2.718 something. So let's say math.e. And there it is, 2.718281, blah, 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 blah. And now we can go math.pi. And now this will give me 3.1415926535897932384 and blah blah blah. And so let's go back to the math class, and you see pi and e, they're both capitalized. Variables that are constants in Java are by convention you write them in all caps. So e, even though it's one letter, it's in caps, and pi is 2 letters, and you put them both in caps. If you were to have a huge variable name, it would still be in all caps. So let's go on to the functions now. Those were the field variables of the math class. And now if you look down here at method summary, there's a bunch of methods inside this math class. Look at all of those. And they're going to help you, and they're going to be great to use. So let's go through a few of them. We'll start out with absolute value. Everybody knows absolute value. It just returns a positive. So we can say math.abs, and that's our function. And remember, it's not capitalized this time. because it's not a constant variable. So it's just ABS, and then it says open parentheses, double A, close parentheses. Double is a data type. Double means it's going to have a floating point value. So you can give it a floating point value, and it will return the absolute value of a floating point or double value. So let's go down to Dr. Java and say, oh, what do you want to do? How about negative 3.14? And that, you should probably guess, will return a positive 3.14. Let's go ahead and do a few more things with this. Let's say math.pi. That will give me the absolute value of math.pi. So I can do 57. It's going to return 57. So it'll just give me the absolute value of whichever value. Let's move on to a few other math functions. We have ceil. You can go through and read some of these and what they do. I'm going to do a few of them. Like, I know I'm going to do max and min. So let's go back to Dr. Java and say math.max. Okay, and it shows here that you need double A and double B. Or you can have float A, float B. These are just different data types, int A, int B. And basically, it's so the function will do the same with all different kinds of numbers. So we're going to give it two values, and it's going to be separated by this comma character. So math.max, 5, let's just give it two easy numbers, 5 and 10, and close that off, and it's going to return the greater value of the two. So obviously 10 is greater than 5, and just to show you, if we switch them around and say 10 and then 5, we get a 10. Now what happens if we say 5 and 5? It's going to return 5, which is the same value. So just kind of know that's what it does. And we can also play with the min function. And let's say 7 and 22. Obviously 7 is going to be much less than 22. But what if it's 7 and 7.0001? Still going to give me 7.0, which is a double value. So here we go. Pretty easy. It's nothing earth-shattering. You're probably thinking, okay, where's the excitement? If you ask me, I think it's pretty exciting learning how to make Java tell you which number is bigger, but maybe not so much for you. So let's do a few more. How about math.random? That one's pretty exciting. So let's say, first of all, I'm going to reset the interactions window by clicking this reset button. Bam. Okay, so math.random. Okay, and if we go back here, there are no arguments, so it's just math.random, open, close paren. So bam, bam. Okay, and it just gave me a random number. I'm going to run that again, and it gave me a different random number. So let's just keep running this, and you see I get all these different numbers. And you're probably guessing, well, it's because it's random. And you would be right. So that gives us a random number. Now, what would you do if I said, give me a random number between 0 and 87? Well, you're probably like, well, math.random only gives me a number between 0 and 1, which is sort of true. It gives you a number between, it's kind of like this. It's going to be 0 is less than or equal to 1, x is less than 1. So the number that it gives you it could be equal to 0, but it is never going to be equal to 1. It'll always be less than 1, so it could be 0.9999999, but it can't be 1, but of course it can be 0. So if I said find me a number between 0 and 87, then what would you do? Well, what I would do, because I already know the answer, is say math.random, And let's multiply that floating point value by 88. And there you see it gives me a random number between 0 and 88, which is it's going to not include 88, but it could include 87. So what if we want to get just the integer value? We don't care about the decimals, we just want the integer value. So that could be the same thing, except we're going to do something called typecasting now, where we take this whole thing, you put that in parentheses, and then you go back to the beginning, and I want it to be an int. We haven't learned about data types yet, but this does mean integer, int. And we're going to put that in parentheses, and then right after that we're going to put this expression in parentheses, and it's going to now just make a random number in between 0 and 87. See how that works? Very nifty. And if you know about computers, computers cannot think for themselves, so they can't truly create a random number. And I believe the way Java does it is it goes off the system clock like in milliseconds, so it might as well be random, and they do some other stuff to the number to make it as random as possible. But remember, since it is working off time, if I run several random numbers in a row, in really quick succession, they might not be also random. Just for example, let's don't watch what I'm doing, but I just say, let's see, int I equals 0, and let's run this 10 times, and say I plus plus. Don't watch this, and I'm just going to say math.random. Okay. And you can kind of see it's going in sort of a pattern here. Not a really great pattern, but we have 5, 8, and then 9, so it's getting greater, and then it's resetting. It's going back to 0, 4, 9, and then back to 3, 6, and then back to 3, and then up to 9. So the pattern's really hard to see, but you know, it could affect your answers. I can actually make this a lot closer. That'll take too long. So that was just a simple loop that I used, and you don't have to know that for now. We'll learn that in probably lesson 7 or 8 or so. So let's go ahead and wrap this up with a few more. I did see POW here, and I want to go over POW. So let's go ahead and reset the interactions window again. Say math.pow, and it's going to be a base and then the power. So 5 to the power of 2 is going to give me 25. And note that it returned to me a double. The pow function always returns a double, static double pow. Okay, so let's give it a 5 to the power of 5. Okay, 3, 1, 2, 5. What if I give it -1? It's going to be 1 over 5 or 0.2. What if I give it 1/2? I can even do 1 divided by 2.0. Okay, it'll give me the square root of 5. So POW function works for any base to any power. Now if you get too large, like if I say 5 to the power of 50, you'll see 8.881 e to the 34, and if I get too large, it will just eventually say infinity. So that's just kind of an interesting thing to know. That's the POW function. Are there any more? There's round, there's all kinds of trig functions, and 2 degrees, 2 radians, pretty awesome stuff. Don't forget you have your pi and your e here. But those are all in the math class. So pretty cool thing to know. And I think we're done with this lesson. And finally, in our next lesson, we're going to learn about variables, and we're going to do some work up here in the actual writing a program window, if you want to call it that. So I'm going to go ahead and reset, and we are done for today. So I will see you next time in lesson 5 with variables. Thanks for watching.